Alright, so we're going to touch on 5.5 continuous random variables here. And the big thing to realize here is probabilities are area under the curve. Okay, so that's what we're talking about here with our probabilities being the area under the curve. In other words, all this space under here, under the curve, that's all your area, okay? So that is the probability. So the values you get is referring to the area under this curve. That's what's referring to your probabilities. Now what's talking about being valid, which we've talked about, is being the total area is equal to 1. In other words, all the probabilities add up to 1. Okay, and so they add up to 1. Or 100%, right? However you do it. If you're doing in decimal, of course, it would be added to 1. However, you're doing percentage, it would add up to 100%. Now, we're going to talk about today, too, start out with, dealing with skewed right, skewed left, and symmetric, and how the mean and medians fall. In which case, which one's greater, which one's less, and which ones are equal. So, as you can see, we have it displayed here. With skewed right, the mean is always going to be greater than the median. Skewed left, the mean is less than the median. And the symmetric is the mean is going to equal the median. So let's go over some of these and show you what those look like. So let's start out here. Let's say we got just a nice little graph here, and let's say we've got skewed right. Okay, so it's going to look like your right foot skewed right. So here's your big toe over here, your peak, right? There's your peak. And it goes down here, the little pinky toe right down here. So there's your bottom part, okay? So with this, what it's referring to is your mean is going to be greater. So again, we're looking at values here. Let's say we'll make this simple. 0, we'll just say go on to 100. If you're going to look at this, the mean is going to be greater than the median because you have these values that are down here on the tail part of it, down here on this tail, that are pulling the mean this way, pulling it that way. The mean is going to go that way. Okay? So your median, again, is mainly always going to be the center point. It's going to be close to your center value. So your median is going to be right here on the peak. It's going to be your peak. So for your mean now, we change colors here so it makes more sense, a little confusing in my eyes. So now with that, dealing with your median is there. The reason why your median and mean don't equal is because, like I said, these values on this tail over here, these are higher numbers, but there's still a few of them. So it's going to pull that mean somewhere over here. That's going to be your mean. So these higher numbers, this tail here, is pushing the mean that way, getting away from the median, because you have these values that are on the higher numbers. So it makes a little bit of sense dealing with that. Same thing with dealing with, we're looking at our skewed left. So if we have a skewed left, I'll write this out here so we don't get confused. This one's skewed right. This one's going to be skewed left. So if we got skewed left, again, we're starting out with our pinky toe. Oh my goodness, that is nasty. So we're starting out with our pinky toe and make it look like that, okay? So again, let's say we still have the scale going from 0 to 100. And with this, your median is going to be, again, where that peak in the graph is. So somewhere in here, right? That's where your median is going to sit. So that's your median. It's going to be where the majority of the values are sitting at. So that's your median value. Now for your mean, because of these values on the lower end, you have lower numbers over here. There's still a good amount of them. It's going to pull this line this way to be able to push the mean. So therefore, we're going to have our mean there. So again, this one, the mean, I ran in the colors here. So your mean is going to be less than your median. In other words, the number value is less than your median. And vice versa for the skewed right. So where you have your mean is greater than your median. All right, so hopefully that makes sense on how that's playing out. But moving on to, if we just had a skewed one, like in our big ideas right here, like this guy right there, if we just had, let's just say we just had this setup here, and we just had a normal bell-shaped curve. All right, we just had a normal bell-shaped curve. Well, because it has an equal pull on either side for the most part, it may not be 100% equal, but for the overall effect, they're going to be pretty similar. So, therefore, your mean and your median, so we'll say there's your median, and the mean should be fairly close to being equal, if not equal. So again, when you just have your symmetric, symmetric bell-shaped curve, which is also considered your normal curve in that aspect. So therefore your mean is going to equal your median. If anything, they're going to be very similar and very close, okay? More than likely though, for the types of issues and problems we're going to deal with, they're going to be equal for a normal bell-shaped curve, okay? When it's a symmetric look like that, they're going to be equal. So that's the big thing we're going to talk about. So now we're going to go into a lesson that I taught for AP students, but it's the same information. We're going to talk about uniform distribution and how to calculate that. Alright, so let's say I changed my mind here, and let's say I want to assign wages that you guys will get an equal amount, or sorry, any amount between $10 and $20, and they're all equally likely. So $10 and $20 and equally likely. And I want you to draw a graph to represent the probability of this distribution. So again, you mean from $10 to $20, all equally likely, and draw a graph. Well, to do that, it's classified as uniform distribution. So we're looking at a uniform distribution. So to draw that out, again, your y and your x-axis here. And I said anywhere from $10 to $20, right? So we'll say we'll have $10 here. And we'll say we got 20 here. All right. So if we got 10 to $20 for wage and it's all equally likely, then instead of having a normal curve, a bell curve, I should have a straight line that goes all the way across, right? Because I have the same probability. It's not as if it's a normal bell curve, right? We're not drawing a normal bell curve to go on that to make that work out because they have the same probability. So in other words, we're going from $20 or for $10 to $20. Well, how do I figure out this height over here? Well, what you need to do is, what is the difference between the max amount you have and the least amount that we go here? If you simply take 20 minus 10, you would get 10. So for the height, it's 1/10. So we have a 1/10 height for each one of these, because therefore you'd have the same probability for each amount in here, no matter what it is. So let's think about that. Let's go ahead and let's do a probability, let's say that makes between $12 and $12.50. So let's say a probability that you make between $12 and $12.50. All right, so let's say $12 is somewhere, let's get a different color. So say $12 is somewhere right in here. So that's $12. And then we'd have $12.50. I'll make it a little bit bigger than it probably needs to be, but just so it makes it a little more visually appealing here, make it a little bit easier to see. So $12.50. All right. So in other words, the probability for that is everything in between these two lines. Right? It's everything in between here. So how do we calculate that? Well, first off, let's calculate the width. What is the width going to be here? So for our width, we're taking 1250 minus 12, which of course you guys probably saw right away is 0.5. Okay? And what's our height? Well, it's given to us, right? It's 1/10. It's our height right there. So we know the height is 1/10. So we got 1/10 and 0.5 for our width. So if we want to find the probability, then we just multiply them together and get the area under that curve. We're just trying to find the area of this rectangle in here. So if I take my length, or my height, times my width, so for the probability, you're taking your height times your width in the situation for uniform distribution. And that will give us, our height was 1/10, and our width was 0.5. And if you calculate that out, you should get 0.05 for the actual probability of making between $12 and $12.50. So again, what that's saying is there is a 5% probability of making between $12 and $12.50 based on the uniform distribution that I said I was going to pay you anywhere from $10 to $20, and you have the same chance to get any one of those values for your hourly wage. Okay, so I hope you learned a little something about uniform distributions, as well as understanding how the skewed right, skewed left, and symmetric mean and median play out. Okay, so remember always to make a valid probability, everything for the probabilities will add up to 1 or 100%, whether we're using, whether it be decimal for 1 or in percentages out of 100%. Again, the probabilities, when you're talking about probabilities, think in the back of your mind, that's always the area under the curve. You're talking about the area under the curve for your probabilities. So think about that. That'll help out in the future when we start talking about this. Last thing I want to talk about to make sure everybody is clear with is understanding what these guys mean here. Again, this is simply saying, like over here on this guy right here, it's saying the mean and then minus 3 standard deviations. So again, this is mean, and this equals standard deviation. Okay? So that's what these are telling you as far as each one of these lines, because you should have 3 standard deviations above the mean and 3 standard deviations below the mean. All right. And we'll go on those as far as percentages and whatnot a little bit more in the future and how that plays out. Future problems will definitely explain that a lot easier. But for the right now, think about dealing with this. You're looking at your mean as your center point. That's where the peak is going to be, your mean value. And then this is saying plus 1 standard deviation to the right. And then you got minus 1 standard deviation to the left. And then so forth. 2 and then 3. Okay? All right, guys. Well, I hope you learned a little bit of something today, and I'll see you next time.